Woo! Spring break 2014 is over. So spring break ended and you didn't bother with coming to school yesterday. So what you missed is volume using the disk method. Now this method is going to involve rotating a region that's bounded by some graphs around an axis, creating a three-dimensional solid which has volume. So in order to find this volume, we first need some graphs. So you see here there is a square root function which makes this pretty little woo, woo, woo. Okay, which by itself doesn't do much. But when you put it with this line, y equals 1/10 x, woo. And then stick this vertical line, x equals 4, right in there. You end up creating a bounded region between the graphs. So what we will do with this region is revolve it now around the x-axis, as you can imagine, creating a three-dimensional solid that will look sort of something kind of like this. So our region, which you see shaded in red here, is going to be revolved around the x-axis, creating a three-dimensional solid. And what makes this solid so nice is that it can be easily sliced into disks. And since from geometry we remember how to find the volume of a disk, or a cylinder as we called it back then, we can now in calculus find the volume of the solid. Now the volume can be found using this disk method, or washer method, as it's sometimes called when there happens to be a hole through the middle of the disk, like we saw in the video. It's found by using this very scary and daunting looking formula, which just so happens to be an infinite number of cylinders added together. The cylinder formula for volume, you may remember from geometry, is pi r squared times the height. That's what it was, and that's kind of what it still is. And so let's see how it's applied using the calculus. Our region that we have here, remember this shaded part that we're revolving around the axis, begins at 0 and ends over here at 4. Starting point and the stopping point. So those become the limits of integration for our problem, 0 to 4. Now what you have to envision is, as you're revolving this region around the axis, you have to think about the heights of this radius, the heights of all these blue lines. Those lines are what's actually being revolved around the axis. And so those heights are what's represented by this capital R of x in the formula down here, the greater radius, big R. That's the outside of the surface. So we just plug that into our formula, which says capital of R of x, which happens to be the square root of x, right? And we square it. Now, because this solid has a hole being drilled through the middle of it because of this red line here, we have to account for subtracting that radius out, right? We're going to remove that much volume, that sort of cone shape part that would be drawn in here. And so that little radius, the little r, is controlled by all these red lines. So the equation for those red lines is this 1/10 x. So we're now going to subtract, we're going to subtract from the big R the little r, which is 1/10 x, which has to be squared. And then we have our integral with respect to x. And so that right there represents the volume of that solid that we saw revolved around the axis. Now we just do a little bit of calculus and solve this stuff out real easy, right? And whammy! That was easy. There's the answer for the volume. 584 over 75 pi units cubed. Got to make sure we got the units on there. And so as you can see how simple this is, finding volume using the disk method. Pretty easy. All right, well, since you missed school yesterday, I'm sure you're really sad that you didn't get to do all these exciting homework problems. So your assignment was on page 666. You had to do 1 through 487,281. So have a good time with that. I'm glad you've caught up, and we'll see you tomorrow.